All right, welcome to the explainer. Every single time you use an app, a website, or even a game, there's a kind of hidden conversation going on in the background. It's a set of really simple but incredibly powerful rules that let software, well, think. So today we're going to pull back the curtain on that hidden logic. Just think about it for a second. When you type in your password, how does that app know if you got it right or wrong? It happens so fast it feels like magic, doesn't it? But it's not magic at all. The answer is a fundamental toolkit that every single programmer uses. They're called control structures, and they're just simple rules that let code make decisions and repeat things. Let's start with the first one. Okay, so first up, making decisions. Let's imagine a little kiosk at a big fan event. It's got to handle all sorts of people differently, right? You've got your VIPs, your students, your general admission guests. How does it possibly choose the right action for each person? For that, code needs a way to pick a path. Well, that's where something called a case structure comes in. And it's basically a smart selector for your code. The best way to think about it is like a sorting hat. It looks at just one piece of info, like a ticket type or a username, and based only on that, it picks one specific path out of a whole list of options. And this is what it looks like in practice, more or less. This is what we call pseudocode, just a simple blueprint of the logic. The code is just asking, hey, what's the hero name? If it's Silong, do this thing. If it's Lila, do that other thing. And for anything else, that otherwise clause is the perfect safety net. It's so clean and surprisingly powerful. So let's bring this back to our fan kiosk. The system just needs one input, the ticket type. If the case is VIP, boom, special access is granted. If it's student, a discount gets applied. For literally everyone else, it just defaults to general admission. See? One clean, simple structure, and it handles everything. Super efficient. Okay, so our code can make choices now. That's great. But what about doing things over and over and over again? Think back to that login screen. If you get the password wrong, it has to ask you again, and probably again. For that, we need a totally different tool, the loop. So the first type of loop we're going to look at is the repeat until loop. I like to call this one the persistent checker. And here's the key thing you got to remember about it. It always runs the action at least one time before it checks if it should stop. It's kind of got an act first, ask questions later philosophy. And this setup, it's absolutely perfect for a login screen, right? The code will just repeat the password prompt until you finally enter the correct one. You have to ask for the password at least once, so this loop is the perfect tool for the job. But what if you need to be, well, a bit more careful? The second type of loop, while do, is what I call the strict gatekeeper. And it is completely different from the last one. This loop checks the condition before it even thinks about doing anything. And if that condition isn't true right from the get-go, the action inside might never, ever run. A perfect example is a video game score. The code basically says, while the score is under 100, keep the game going. Makes sense. But here's the trick. What if the player's score is already, say, 105? Well, our strict gatekeeper checks that score first, sees the condition as false, and just skips the loop entirely. No action needed, so none is taken. So let's put them side by side, because this is the most important part. Repeat until is our persistent checker. It checks at the end, so the action is guaranteed to run at least once. While do is our strict gatekeeper. It checks at the very beginning, which means the action might never happen at all. So when you're coding, it all boils down to one simple question. Does this thing have to happen no matter what? All right, so there you have it. That's our toolkit. We have one structure for choosing and two for repeating. And believe it or not, with just these three simple tools, we can now map out the entire logic for our fan event system. Okay, let's actually build this thing out step by step. First, that secure login. We need the password prompt to show up no matter what, right? So we grab our act first loop, repeat until. Perfect. Step 2, assigning parking spaces. Well, that's a classic sorting problem, so we use the case structure to handle all the different ticket types. And finally, step 3, the minigame. The game should only run while the score is below the target, so while do is the obvious choice. See, each part of the system has a problem, and one of our tools is built to solve it. And look, this isn't just some abstract exercise about a fan kiosk. We need to zoom out for a second, because the big takeaway here is that these few simple rules aren't just useful. They are, well, they're everything. They are essential to pretty much all software. So let's do a final check on our toolkit. What this really shows is that for any common problem in programming, there's a specific tool. You need to sort options, you use case. You need to guarantee an action happens at least once, you grab repeat until. You need to be cautious and check first, that's what while do is for. Programming logic isn't about memorizing a million commands. It's about knowing which fundamental tool to use for the job. Seriously, every time you check out online, play a game on your phone, or use pretty much any app, you are watching these exact structures do their work. They're like the invisible grammar that makes software feel dynamic, responsive, and even intelligent. There's a really great way to think about all this. Without these structures for choosing and repeating, your code is like a playlist that can only play one single song, over and over forever. It can only go in a straight line. These tools, this is what gives code a brain. So from now on, when you log into something or choose from a menu, you'll know the secret. You'll see the hidden logic playing out. These are the simple rules that build our incredibly complex digital worlds. And that really only leaves one final question for you. Now that you see the rules, what will you build? Thanks for joining The Explainer.